In this session, we will look at some of the key calculation strategies being used to develop understanding in addition and subtraction at first to third level. I'll provide some ideas on how this learning happening in schools can be supported at home. These strategies help to develop number sense. It is this number sense that underpins understanding in mathematics learning beyond number calculations, for example in topics like patterns, area and algebra. There are 5 key concepts in numeracy which are relied upon across all stages of numeracy in mathematics. They are being able to count on and count back within the number range that you are familiar with, being able to bridge 10, 100, 1000 and adjust. This is a concept we'll look at further in this video. Looking at the complements to 10, 100, 1000 are key to be able to understand a lot of elements of numeracy. So for example, knowing that 4 adds 6 makes 10 helps you to understand that 40 adds 60 make 100 and that 400 and 600 make 1000. It can also help with decimals like 0.4 and 0.6 making 1. The next key concept is being able to double in half. Children all the way through mathematics find doubling numbers and halving numbers relatively easy, and this can help with calculation strategies. The final concept we're going to look at in this video is the concept of partitioning, being able to break numbers into parts which are easy to use. As mentioned in session 1, the approach to teaching and learning numeracy is based on a concrete, pictorial and abstract approach. Concrete representations are any hands-on materials used by children to help understand numeracy concepts. Pictorial representations involve drawing sketches representing the concrete understanding to make sense of the numeracy learning. And abstract representations are what we would call formal mathematics, the use of numerals, letters and mathematical symbols to describe the mathematics we are doing. It is very common for children to develop an understanding of number using concrete and pictorial representations before being introduced to abstract representations. Children can be spending a lot of time developing their understanding of number using these concrete and pictorial relationships before the abstract relationships are introduced. A really helpful concrete and visual aid are 10 frames. 10 frames are used throughout early to third level to support the development of number sense and in particular the development of addition and subtraction strategies. The use of the 10 frame is really helpful in developing the understanding of bridging 10, like this example here. A 3 is taken from the 8 to make another tidy 10, giving an answer of 45. The use of 10 frames as a visual aid can really help support children's addition strategies. The use of this bridging 10 concept can help with more complex calculations like this one, giving an answer of 75. Everyday items like egg boxes can be used to create 10 frames. Drawing a 10 frame on a piece of cloth makes the 10 frame portable. Or in the outdoors, we can use sticks to create 10 frames for collecting items together and counting quantities. The use of games is a great way to engage children in learning numeracy. The East Ayrshire Numeracy and Maths blog has a dedicated area for family learning. Within this, you will find a number of links to a number of resources to help develop games-based activity and activities that can be used in the home and in the outdoors. Within this area, you'll find a link to the 123 Go Maths activity booklet developed by the Scottish Attainment Challenge teachers in East Ayrshire. A really good resource for activities with children. For those of you working through this full series, you'll already have seen a connection between this session and the previous session. The development of the concept of a part-whole model is very important for children to understand relationships in addition and subtraction. This part-part whole model shows the relationship between 23, 34 and 57. Covering up numbers within this part-part whole model prompts children to think about this relationship. What number is covered here? The numbers used within these part-part whole models can be as easy or as difficult as you want them to be. For example, decimals could be included, or even fractions. What number is covered now? Another representation of this part-part whole relationship is using a bar model. This is how the relationship between 34, 23 and 57 could be shown. Once again, covering part of the model can generate problems to be solved within this relationship. Number lines are very useful tools to support children as they develop addition and subtraction strategies. These empty or blank number lines assist children as they develop number sense. For example, if a child was looking to add 26 add 7, they could use the number line to help them with the partitioning of the 7, adding the 4 to the 26 to make 30, and then showing the 3 moving on from the 30 to give them a final answer of 33. The use of number lines for adding in chunks can be extended to larger numbers. Why not have a go at this one yourself using a number line? A possible use of the empty number line here would be to firstly add the 100, then add the 20, and then add the 1 to bridge the 10, and then 3 to get to a total of 333. The empty number line or blank number line can also be used for subtraction calculations. If we start with the largest number to the right of the line, we're aiming to remove the 47. How would you go about removing 47 from the 132? I tackled this problem by partitioning the 47 into 32 and 15. By firstly taking away the 32 from 132, I took myself down to a friendly 100. I then subtracted 15 from the 100 to give me an answer of 85. You may have removed the 47 in a different way, but that's okay, as long as you got the answer 85. A different strategy to employ here would have been to subtract 50 and then adjust up by 3 to take you back to 85. Once again, the blank number line or empty number line supports this thinking. The use of number lines can support the understanding of subtraction being the difference or the gap between numbers. By placing the smallest and largest numbers on the line, the gap will determine the difference between the numbers, giving the answer to the subtraction. Starting at the 68, I add 2 to make 70, I then add another 30 to make 100, and finally add 23 to make 123. In total, I've added 55. This gives me the gap between the numbers, or the answer to the calculation 123 minus 68. This approach is sometimes referred to as shopkeeper subtraction, and reminds me of the days when shopkeepers used to count back your change, and 3 makes 70 and 30 makes £1. The empty number line is also helpful when a slight adjustment can simplify a calculation. The gap between the numbers is the answer to this calculation. Children can find calculations like this difficult, but if we increase the 29 to 30, to keep the same difference we need to increase the 53 to 54. This can be visualised on the number line. This makes the calculation much easier for children. 53 take away 29 now becomes 54 take away 30. Hopefully you can see the benefits of the empty number lines to support the development of these calculation strategies. Not all strategies for developing addition and subtraction rely on visuals like number lines. In this example, each of the numbers are partitioned using place value. we have 100 plus 200 given 300, 20 plus a 30 given 50, and the 4 plus 5 equaling 9. By adding the 300, the 50 and the 9 together, we get a final answer of 359. Place value addition. Children have a tendency to apply this place value strategy to subtraction, but this can cause some issues in cases like this. Children would do 70 take away 30 gives 40, then do 8 take away 5 gives 3, giving a wrong answer of 43. However, if they can handle negative numbers, this strategy can be quite powerful for mental calculation. So doing 70 take away 30 given 40, and then keeping numbers the correct way round and doing 5 take away 8 gives negative 3, by combining the 40 and the negative 3, they get the correct answer of 37. A really nice strategy. As mentioned in the key concepts in numeracy, the use of doubles is something children find quite easy. In this case, recognising 26 is 25 add 1 can simplify this calculation as long as they can double 25. In this session, we have looked at some of the key strategies being used to develop understanding in addition and subtraction at 1st to 3rd level, and to provide some ideas on how this learning happening in schools can be supported at home through the use of accessible, concrete material and simple images. Having a variety of strategies that can be used to answer a question helps learners become flexible in their use of number and challenges learners to think of the most efficient way to get to their answer. It also helps support the understanding that there's more than one way to solve a problem. Correct answers and fluency are always the main goal, but a learner's explanation of how they got to their answer reveals how efficient and how they think when presented with number problems. Your child might be involved in number talks in school, where they are presented with number problems and challenged with using different strategies to focus on the most efficient for them. This approach helps develop a growth mindset. Please have a go at using some of these strategies for yourself, with addition and subtraction calculations. In the next session, we will look at multiplication and division strategies.